So this video is going to show the NGL camera in action. Now it's important to know that the NGL camera is a very general, easy to use camera. It's got certain things in it that makes it quite easy to use, such as being able to roll the camera, do pitch and yaw. It is no way perfect, and it's not there for specific things. So it's really hard, for example, to turn this into a first-person camera for a game. You will need to write your own code to do the controls in the way that you need. And also for doing sort of various other things like orbiting around things and other more complex things, it's always better to write your own. This is very much a generic camera based on the camera that's in the Hill book, which is worth having a look at if a little old now. So it has a basic default constructor which will go through and create some basic elements for the camera. We have a very simple default camera. Again, it's not particularly useful, but it just sets a basic viewing volume. And then we've got methods to do things such as set the eye looking up, and also set the projection matrix internally, and allow us to do sort of various things like setting the camera shape, aspect ratio, view angle, and so on. And there are, internally, it calculates its own matrix, which we can then access by making calls to the view and project matrices. So there's sort of helper functions built in. So for example, if we call get view matrix, it will return the current view matrix that's been calculated. Get projection will get the current projection, and there's get VP, which will return view times projection, which can be useful, just makes life easier. So the simple NGL demo, which I've got here, has a basic camera created here. So it's just constructed using the default constructor. Then internally, when we initialize GL, here I'm going to create my basic camera. So here I've got the camera going from 111 to 000, up is 010, and I'm setting it to from to and up. And then I set my shape here. However, you will also notice that every time we resize the screen, I'm calling set shape here, passing in the new aspect ratio. And that allows us to, when we run the program, allow us to change the camera relative to the screen position. So you'll see that as I resize, my aspect ratio changes accordingly with the screen. So that allows us a lot better control over how we do it. Again, like the previous demos, every time I draw an element in the screen, I'm calculating my mouse rotation here. In this case, it's being created as an attribute of the class. And then when I load to shader, I'm loading in my model view and project here. So I calculate model. I calculate my model view by calling get VP, and my model view project via that. And all of these elements are loaded directly into the shader. So my input attribute is a vec3 again, and my GL position is my model view project multiplied by vec3 there. So it's very easy to sort of just create a basic camera. There is another demo that comes with NGL which does a similar sort of thing but slightly more complex setup. So we have a demo here that's actually creating an array of cameras, and it allows me to, from generating those array of cameras, switch between them very quickly. Because at the end of the day, all we're doing is we are passing matrices to our shader to do our shading. So in this demo here, we have a stood vector of NGL camera called mcameras, and there is a method within my initialization, which goes through and sets up the cameras here. So you can see I'm just creating 4 different cameras, and each one has different positions as we go through. And then depending upon my drawing, when I load my matrices to the shader, you can see now that I'm just indexing into that camera array. So now I can generate multiple views. So here's my scene here. I can just switch to the different cameras. Effectively, all that's doing is changing which matrix is loaded to the camera. This also has the ability to change the roll, pitch and yaw of the camera. So this is rotating around the n-axis, so we're doing a roll around through like that. We've also got the ability to do pitch, so this is the axis going off to the right, and that will eventually come back. You can see it's a rotation there, and we can do yaw as well, which goes through. Also, again, we've got the ability to move the camera around, which makes a call to set eye or set look. So at the moment, if I activate just moving the eye, you can see I'm moving the eye in various directions. What that does is recalculates the view matrix each time, gets it loaded to the shader. So moving the eye has the ability to do that. What we can do is move look instead. Again, it's just recalculating each time. Typically, this is sort of the thing that you would do if you're doing sort of first-person style cameras, that you would be recalculating these. But it can be done far more efficiently than this general-purpose camera. And we can move both eye and look at the same time as well, which gives us the ability to do sort of more useful style controls. Again, a bit more first-person-y, but we can move things around. Also, we can change things like the field of view. So by changing the field of view, you can see that we get our projection happens differently there. And by taking it out again and making it larger field of view, you can see that we get our perspective projection changing until we get to very wide. See, once it gets towards 180, it disappears because our field of view is wider than it can be. So we can do some quite effective things using this camera. As I say, it's a general purpose camera. It's not necessarily suited to certain applications that you may want to generate when you're doing things such as first-person games, and you're always better off figuring out what it is you want and writing your own camera, calculating your own matrices.